I did find something strange, which is this. This is like, this looks like the most important thing I've found. Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Nameland, who has been the greatest living philosopher before me. So, you may remember my paper about solar flares. I've made a video about it, I'm going to link it in the description. And back then, I've made this list of what I want to do further, right? The extended program, as I call it. So, there's plenty of stuff over here, and I've already outlined it back in the day, back in July of 2021 when I was planning this research. As you can see, it took me like 2 years essentially to actually start it. But yeah, the results of this initial thing are in my paper that's already out. Again, see the link in the description. However, I wanted to do this extended program. I wanted to look, is there any patterns in where the flares are directed in the sky specifically, right? Like this thing. So I did that, and this is like, it's gonna be pretty chaotic. I have to apologize for this, but like, okay, a bit of a background info. So I've worked on this topic for like 3 months, something like this. So I did a lot, okay? That's kind of the bottom line. And yeah, but I got disappointed at the end because I didn't find anything super spectacular. But I actually put a lot of effort in all of this research. And we're gonna talk a little bit about what I found. And this is like my diary of my results. I'm sorry for this. Yeah, this is like my diary of my results that I made for myself essentially. Like I just put stuff here along the way, right? You will see some of the scaffolding behind the research, like how it actually happens. And this is kind of the video which, like, by the very nature of it, it's just, very raw in this sense, okay? So, this is the conclusion I've arrived at. There are no preferential directions in the sky for the flares. I was really hoping to find something. But I didn't, okay? Yeah, and this is my main working tool. As I've said, I'm working in Wolfram Mathematica, not sponsored, unfortunately. Well, yeah, I introduce a bunch of functions, like I calculate a whole bunch of stuff, etc., etc. But in terms of the directions of the flares, we're talking about X flares, by the way, so strong, the strongest ones. I didn't find any patterns. This is how it looks, where the length of the arrow corresponds to the magnitude of the flare, and the direction is literally its direction in the sky. So how do I do it? How do I find this direction? Well, from my previous research, I have this database of flares and where they occurred on the sun, right? And if I know the position of the Earth at this moment in time, I can easily actually calculate where the flare is directed if I know where it happened on the sun. Obviously, we're only talking about the flares that we can see from Earth, because this is the data that we do have. We don't have actually a good data set of, 360 distribution of flares on the sun, but it's good enough at the very least, right? At the very least, statistically, we can say that we have 1/2 of all the flares taken account of. Actually, a bit more than that, because again, see my previous video, the flares that happen behind the solar disk are sometimes still visible because they happen in coronal loops, which are situated above the photosphere. Okay, so yeah, this is my conclusion, unfortunately. There are no preferential directions in the sky. And I think I have a plot somewhere which shows this. Yeah, this is roughly the black ones, the black dots, are where the flare directions, right? And I think this is the solar equator. I could be wrong though. No, it's probably too tilted for the solar equator, but I don't remember to be honest. Like there are something. It could be the Earth's equator. I don't know. Like I did this some months ago, so I don't remember anymore. This is, in case you're interested, I was plotting where the barycenter of the solar system was during the flare. So again, the size of the dot represents the magnitude of the flare, and the position is where the barycenter was. This is like viewed from the top, right? And this is the sun. No patterns here either, to be honest. And this is like a cross section, like this is the ecliptic, right? The horizontal, and this is north. So no patterns here either. There are some graphs corresponding to this, like vertical displacement of barycenter with respect to the solar equator, and flare number just means in my catalog, like I have 300 and something, 307 or whatever X flares that happened from 1991, where I could find images, X-ray images of the sun. Starting with Yoko satellite, and then SOHO, and then SDO, obviously. This I don't really remember what it is. It's probably also something like a barycenter. So yeah, the conclusion is unfortunately such. Then I looked at where the planets were, and the barycenter I've just shown you. So barycenter position is not related to flare direction, and none of the planets are related to flare direction, so it's completely random. This is actually incorrect. We'll talk about this later. It's the only kind of positive thing I've found, which I'm pretty sure is legit, but I have no explanation for it yet. But as you can see, I've done quite a lot of work. Like, yeah, this this is my comment to myself. Like, imagine you're doing this research for like a month and you find nothing, and then you find something, and that's your honest reaction, right? So what do I mean by Mercury chasing Venus? I'll have to explain it to you. So imagine, like, for example, this is the orbit of Mercury. It's too big. And let's say, let's say this is the orbit of Venus. I'm well prepared, as you can see, right? So if Mercury is, let's say Mercury is somewhere here, and Venus is somewhere here. This is what I call Mercury chasing Venus, because Mercury is faster, right? So as it orbits, it's gonna catch up to Venus. So this is what I call chasing. If Mercury is ahead, like if it's here, it's gonna run away from Venus, right? This is what I call running away from. So there is this line where if Mercury is in this area anywhere, it's chasing Venus, and if it's anywhere here, it's running away from Venus. This is my terminology, okay? We probably don't need this anymore. So yeah, somehow almost 2/3 of all the strong flares happened when Mercury was chasing Venus. So when Mercury is lagging behind and it's catching up. I have no explanation for this. I highly doubt it's anything gravitationally related, like tidal waves. I mean, this is kind of the obvious explanation, but like, why? You know? I'm very skeptical, by the way, about the tidal influence type of explanation. I think it's completely negligible. It's only my opinion. What else could be at play here? I don't know. Like, no idea at all. You will see later that I have an alternative hypothesis of how this could work, for which I've spent almost a month trying to prove that it's true, but it's wrong. So yeah, it's a huge disappointment in this sense. But there could be alternatives to gravitational explanation. That's what I'm saying. But they wouldn't work in this case, in this particular case. So I have absolutely no idea what's going on. But this seems legit. Like, look, this is publishable, you know, p-value of a millionth. This is insane. But it's actually the case because, again, there's a lot of these flares, right? So, well, in case you don't know anything about statistics, the bigger your data set, the easier it is to get these super low p-values, which means like very good statistical significance. I even calculate the Pearson coefficient and Spearman coefficient and things like that. And they do, like, it's a weak correlation, this, technically, right? So there is noticeable difference between when Mercury is chasing versus when it's running away. So when Mercury is chasing, there are much more flares, almost 2 times more flares than otherwise. Well, more like 1.5 times, right? Then there is this, slightly worse, right? But p-value is still good, like, you know, 5. If we have 5 here, it's good enough. Like, it's considered to, but it, obviously, I mean, it's a magical number, right? It's just a convention. Then slightly worse with Jupiter. Pretty good with Uranus. Again, I have no idea what's going on. Like, this seems to be the most important. No explanation though, no idea. And some other similar stuff, like Mars and Barycenter. I've checked this as well. No idea why. Jupiter is running away from Barycenter. Obviously Jupiter is the main factor in where the Barycenter of the system is, because it's the most massive planet. Incredibly low p-value, very strange. So basically this is like Jupiter's position with relation to Saturn, basically. Saturn and Earth, kind of. Again, no idea why. Then we have some notes that I've made for myself. Kind of returning to this, you know, a couple of months later, because again I was so devastated by like the negative results I got that I just completely lost my enthusiasm and the will to continue this research. So I'm not gonna publish anything probably, maybe this, because again this is strange. But there is a paper that I want to show you, this one, which did something similar. So I'm not sure if another paper is needed on this topic. You can look it up if you wish. Okay, so where we're at. Wait, do I have the 2 of it now? Okay. Yeah, big thing, like the theory, the alternative hypothesis I've had is, well, if it's not gravitation, maybe it's electromagnetism, obviously, right? And how can the sun be influenced electromagnetically by the planets? So at one of the Observing the Frontier conferences that I've attended, by Ben Davidson, the organizer, right? There was a woman from, like, she studies solar cycles, right? Lisa Upton, I think, is her name. They've made some, like, predictions of cycle 25, that's why she was there. So she gave a talk on this topic. So at one of the, you know, breakout room sessions, we talked about like how, again, planets may be influencing the solar flares, and that's what we're gonna discuss here. So she said, how is this possible if the solar wind is supersonic, right? Which means that, you know, no signal can be channeled backwards towards the sun, because the solar wind itself is like a shock wave, it's supersonic. But this is wrong. Signals can be channeled towards the sun via, for example, or via, whatever, Alfven waves, or any other plasma waves like in general. There have been detected, I can show you papers, sunward Alfven waves. And they have been detected not only near Earth, but in other places as well. Which means that these waves can propagate along the solar plasma and reach the sun from the planets. Okay? So this is one potential mechanism, like actual physical mechanism of how planets can actually, ring a bell at the sun, so to speak. So I did this. I've calculated the velocities, the time it takes for Alfven waves to reach the sun, somewhere here. Actually don't know where it is. Yeah. So it's pretty tricky, because Alfven waves velocity depends on plasma parameters, and they depend on the distance from the sun. So we're solving an quite a nonlinear integral equation, essentially. Okay. So I use this paper for reference. It's great, actually. I recommend you if you're into it. So they have a formula here, which like analytically represents the parameters of the solar wind, such as density, velocity, magnetic field strength, and temperature. I didn't care about temperature, I don't need it. But Alfven waves velocity depends on density and magnetic field strength. And yeah, and I've calculated this. And I've calculated how long it takes for the Alfven wave to propagate. But here we should talk about the solar wind a little bit more specifically. So, as you can see, I did my homework, as they say. Again, it's a couple of months of research that you're looking at. A couple of months of my life essentially wasted, considering the results. So, general comment, right? I get very angry when people tell me that planets influence solar flares, exactly for this reason, because I've spent a lot of time trying to prove that this is the case, and I found that it's not. At least, I don't think it is. Except for these mysterious cases, okay? Like, this seems legit. I don't know, like, where it comes from. I don't know what it means, but it's very strange. Except for that, planets have no influence on the sun. At least I didn't find it. Yeah, what I wanted to show you is how solar wind propagates. Okay, we may use this as our reference. So the sun rotates, spins around its axis, and as it does so, the solar wind gets curved, right? So-called Parker spiral. So Venus, in this case, catches not the solar wind from right in front of it, so to speak, on the sun, but from a little bit like some other place, right? The solar wind that should be going there, roughly, right? So, I thought, what if these Alfven waves can propagate along this channel, right? And maybe when two planets combine, like, imagine Mercury was sitting over here. So the solar wind kind of connects Mercury and Venus at this point. And maybe there would be some disturbance that would propagate towards the sun, hit it, and cause a flare, or something to that effect. I have a fancy name for this, by the way. I call it plasma astrology. So it's like not just straight lines, but actually these curved lines that connect the planets. So I would call it like a plasma conjunction, right, when Mercury is here. Even though it's like you can't actually see it, right, because it's weird. It's this curved line. So it doesn't look like a conjunction in a traditional astrological sense or whatever. But it's physical, right? They are connected by plasma, and they can influence the sun, as I've said, through Alfven waves. So I've worked like almost a whole month developing this idea and looking at patterns, like to see if it actually works for the sun in terms of flares, right? I have somewhere here, I have like an archive of images that I've produced of my simulations. So one such picture, because we're solving this integral equation, it takes about like 5 minutes to calculate. So we're looking at literally a week of my life in these pictures right now. Something to that effect. But it's just to show you like how it actually looks, right? So when Mercury is here, right, I say that it like there's a conjunction of Mercury and Venus, and maybe it influences the flare, but there could be a lag, right? Because I've calculated the time it takes for an Alfven wave to reach the sun. Again, the velocity is variable, etc., etc. But I have should be somewhere here, like the time specifically. Yeah, let's do a search. Yeah, maybe it's one of these, but this is roughly what I got. So it takes 19 days from Mercury, 30 from Venus, almost 40 for Earth, 56 for Mars, etc., etc. So it's a very long time actually, right? So it's all of it is very, how would you say, like non-trivial. It's very hard to see. Unfortunately, as I've did this and I've looked into like when do the planets connect. Yeah, I was so optimistic back then, right? So when do the planets connect to the sun through this plasma, like when these planetary plasma conjunctions happen? It's completely random with respect to flares. Like the flares don't, they don't depend on it at all. In fact, sometimes I got much worse than random results, in the sense that, well, basically it has zero predictive power in terms of flares. That's kind of what I'm saying. Yeah, it was very tricky actually to calculate all this, the time it takes, because again, not only is the velocity variable, but this curve, I don't have an analytical expression for it. Like every curve is iteratively computed, like every such curve that you can see here. That's why it takes such a long time to make, because I'm basically integrating this velocity graph. I calculate how long it takes for the sun to rotate, and then I can have an idea of which angle should be in this Archimedean spiral, so-called. It's not exactly Archimedean spiral, again, because the velocity is changing, the velocity of the solar wind. Yeah. Also, one problem that, like one issue with this approach that you can have is that, well, you know what, like, it's the calm solar wind, right? And it's like the slow solar wind. But what do we do when we have a CME that comes here and like completely disrupts this magnetic line? And like, yeah, it's a problem, you know. Plus, if we have a fast solar wind stream, it's much more straight. Okay, so there's also a problem of this sort. So even though I was very diligent in calculations, like I've used this formula for the solar wind, but it's a slow solar wind. You can see the velocity. It's around 400. It's a logarithmic plot. So 10, 100, 1000. So about here is 400. 400 and something perhaps. Yeah, so there's a problem with this sort. But anyways, there should be something similar. I mean, I should have found something if it was there. So like, the fact that I didn't find anything was very, very devastating for me emotionally, to be honest. And again, that's why I've abandoned this research, at least for the time being. So yeah, these are my conclusions. Like, this is weird. I have no idea where it comes from, but it seems legit. Other than that, planets do not. Oh, and by the way, yeah, I've already mentioned this paper. Like, it's pretty good. Like, I got the graphs very similar to this. Maybe I can show you. Yeah, like, there should be. Yeah, so something like this. This is like the angular separation of the planets. Also, one thing I want to mention, and I would advise any of you who want to continue this research or do a research of your own, not only did I look at the temporal lag, like as you can see above, we have the Alfven, Alfven waves take a lot of time to reach the sun. So I had to study like what happened like 200 days before the flare, basically, right? Kind of hoping that maybe I will catch something. So not only did I look far away into the past, like again hundreds of days, but I've also looked into the future. And this might sound weird, but physics is time reversible. So a future connection can cause things in the past. You might think this is crazy, but it's not. There are some interesting effects that are connected to it. But decent people shouldn't think about it. I'm just telling you that I've looked into it, like what will happen 200 days into the future, roughly speaking, which connections would appear. But yeah, the end result is that it doesn't matter. I didn't find any effects. I'm just telling you that the lengths I went through to study this is really kind of, it was a lot, okay? You can see it, right? I've tried to make some like predictive model, again using these previous graphs that I have. So basically, like, how probable is the flare right now with respect to what we've already seen? Like, are the planetary configurations anything near what happened previously during the flares? So that's how I did this, but it didn't really work again. Well, I did this kind of for fun, to a degree. You may actually double check, like you can see the graph, what happened in July. I think I actually got some of the flares correctly, but it's just luck, to be honest. Yeah, what else did I wanted to say? Well, in general, like general concluding remarks is that, well, first of all, outer planets, their relative positions do not matter. Why? Well, because, if it takes more than a solar cycle for the planet to move, how do you expect it to be of any influence on a smaller temporal scale phenomena such as solar flares, which we have like hundreds, if not thousands of them, I mean, depending on the class you're looking at, during each solar max, which, takes like 5 years, solar maximum. And so if you have an orbital period of like 70 years, how do you expect it to influence this in any way? The inner planets, yeah, they might influence through maybe tidal connection or this plasma astrology type of connection that I've invented that doesn't seem to work at all. I still love the idea. I mean, you gotta appreciate it. It's kind of beautiful. It's such a shame it doesn't work. But that's kind of the motto of this research. It's such a shame it doesn't work. It would be so cool if it did, but it doesn't. So yeah, long story short, planets do not influence solar flares. And if you claim otherwise, I would dare you to prove it to me. I've spent way too much time studying this on my own and finding that it's not working. So if you claim it does work, I will be very harsh to you. I will ask you for some serious evidence. However, again, I did find some. As you can see, there are again my notes to myself. I did find something strange, which is this. This looks like the most important thing I've found. Maybe I will publish it at some point, but I don't know. This doesn't seem like an artifact, but then again, like, what's the physical mechanism? I have no idea. Absolutely. What does it mean? No idea. Anyways, that will be all probably. So long story short, again, the flares, at least strong solar flares, X-class, do not depend on planetary positions whatsoever, neither in the past nor in the future. Oh yeah, the philosophical remarks I wanted to make. So, okay, this is gonna be hardcore. Okay, so brace yourselves. The planetary motion seems very organized, right? It's very regular, whereas the solar flares seem very irregular. It's almost like the sun has a free will or something like that, right? So it's regular in general because it's a cycle, but it's very irregular on a smaller time scale. So, like, fundamentally, I don't see how a regular process can influence irregular process. So, like, this particular flare that happens right now, how can it be caused by some regular motion of planets? Think about it. I don't think it can. And more hardcore philosophical, like, if you think about it, there might be some intrinsic periodicity to the flares, right? And maybe the planetary periods kind of mimic this periodicity just by virtue of, Fourier series. Like, you can disintegrate any periodic process into a bunch of sine functions, roughly speaking, into a bunch of smaller, like, periods, components, rather. So maybe the planets only mimic the intrinsic periodicity of the sun, but they do not influence it. Think about that as well. Okay? But yeah, hopefully you got something interesting out of this. I don't think I have anything else to add. I think I've discussed everything. So yeah, thank you for watching. The eons are closing. If you wish to support me, please consider joining my Patreon. That is patreon.com/philosopher. See the link in the description. Or if you have a scientific theory of your own and you'd like my help in developing it, please join my alternative science coaching program, also available through Patreon.